and model the Titan 86L. This is a lathe part, so it's turned on a lathe. With that in mind, when we're designing lathe parts, because it's a cylindrical part, we can actually draw half the part and revolve it around a centerline axis. Very first thing that we're going to look at is our blueprint. We have our front view right here. Notice our front view, it's got a diameter running through the center of the part at 560 thousandths, and the outside diameter of our part is 950 thousandths. Notice we also have a section view here from going from A to A. Right below it, we have our bottom view, and in our bottom view here, we have our section view, and within that sectional view here, it's giving us the dimensions of everything. To the right of our front view, we have kind of our right view indicating some corner radiuses and a chamfer. And then to the right of that, we have our isometric view, kind of giving you a visual representation of what this thing is going to look like. So let's jump on over to Fusion 360 and we'll make this part. I'm over here in Fusion 360 and we're about to make this part. We're going to start off using some lines. So I'm going to go L on the keyboard. I'm going to click on my top plane. Just like all my other parts, we always like to anchor the beginning of our sketch at our datum location or the origin. So we're going to start here. Now the height of our part is 640 thousandths. So I'm going to make that line 640 thousandths and then zoom in and drop our measurement down here. Okay. Now what I'm going to do is I'm going to come around and I'm going to kind of draw real briefly what this part kind of looks like. And notice I'm not adding any sketches or any dimensions in here. There's very few constraints being added in, except for the automatic ones that Fusion 360 is adding. Notice that this line's not even straight up and down, it's coming in at an angle. That's alright. After the fact, we're going to come in and add some constraints. I'm going to say that this one is perfectly vertical. I'm also going to say that these are perfectly horizontal. Notice this arrow came up, indicating that it's already defined. Now what we're going to do is we're going to add some dimensions in. So D on the keyboard. We're going to come off our datum location to this point. And according to the print, the diameter at this section is 950 thousandths. So 950 divide by 2, because we're talking about radial measurements. So the other constraint that we should have added in that we missed, that's all right, is we're going to also put in and say that this point and this point are also horizontal to each other. I missed that one. Okay, so we have our outside diameter. Now we're going to constrain this point, so D on the keyboard, coming to our datum location. And according to the print, it states that is 732 thousandths. So I'm going to type that in. Oops. And then make sure you divide it by 2. $732 divided by 2. And I may have to go back. Two divided by 2. There it goes. So at any point, if you make a mistake, you can always hit the undo button up here. So notice how I made a mistake. We all make mistakes. and all I did was kind of go back in time on that. Next thing we need to do is we need to constrain these endpoints here. We're going to go D on the keyboard, coming from our datum. This one here is 125 thousandths. Coming from our datum to this next endpoint, this one is 590 thousandths, just like that. And then our center point here is 358 thousandths. So notice it kind of reshaped everything. This is a good point where you can hit cancel and kind of move your dimensions around, reorganize things. As I've mentioned a couple times before, is when you open these parts up, you want to be able to just visually and quickly look at the dimensions and make sure everything looks all right. Okay, we have the outside profile of our part right now. So now's the time that we're going to take our sketch and we're going to revolve it around our center line, making a three-dimensional part. So we're going to go to Solid, Create down to Revolve. Here's our profile. In our pop-up window, we need to make sure axis is selected. We're going to choose our axes. And then notice we have our three-dimensional shape now. Okay, at this point, we're going to add in some of our external features that we missed on our sketch. So right in this groove here, if you look at the print, there's a 100 thousandths radius. We're going to go to Modify down to Fillet. We're going to click on that and type 100 thousandths in. On the edges of our part, so this edge here and this edge here, those have a chamfer on them, so modify down to chamfer. I'm going to click on those two edges. Now, as stated on the print, those are 10 thousandths at 45 degrees. So notice now we have our part, or the outside of our part. Now let's take a look at the inside of our part. So if you look at the print, section AA, there's a bore going down the center of our part. In addition of having that bore, it looks like there's an O-ring or like a grease groove or something in the center of it. What we're going to do, you're going to pick a side. Doesn't matter which side it is. However, I'm going to pick this side. The reason why I'm picking this side is our datum reference was on the face of this. It'll make things a lot easier when it comes down to measuring things. So I'm going to click this face right here, Create, down to Sketch. What we're going to do now is we're going to create a couple sketches on here. And these sketches, one is going to indicate the hole going down the center of it. If you look at your front view, there's a 560 thousandths diameter hole going through it. C on the keyboard will give us a circle. This particular circle, we're going to snap it to the center where our datum is. 560 thousandths, just like that. In addition for this particular circle, we also have that O-ring or grease groove. And that particular diameter is 624 thousandths. So C on the keyboard. I'm going to type in 624 thousandths, just like this. I'm going to drag one of these measurements around so we can see that there's two different measurements there. I'm going to right click, press and pull. I'm going to click on the 560 thousandths circle first. Notice if you come in and orbit the part around, you have that blue arrow. In my pop-up window, I'm going to go over to the extent drop-down window. I'm going to go down to all. And notice that this pink red area is showing here. And it's showing that it's going to be cutting all the way through the part. Notice our operation is cutting. I'm going to press OK. Notice we have a perfect 560 thousandths diameter bore going through our part. But as soon as I created a feature off our sketch disappeared. So I'm going to go back to my browser window and turn the sketch on. So I have our sketch for our O-ring groove. I'm going to right click, press and pull. This time I'm going to press and pull this little donut shape here for our O-ring groove. And in my pop-up window, what we're going to do, this is very similar to like the Titan 8, which was the binoculars. We're going to offset this sketch from the top down, and then we're going to bring it back up. Well, if you look at the section AA, it says from the top of the part, the bottom of the O-ring groove is going to go down 200 thousandths, and then the O-ring groove itself is 100 thousandths tall. So I'm going to go to Start, Offset. My offset is going to go down, so minus 200. And then we're going to go back up 100. So my distance is 100 thousandths. So notice in our preview here, we're dropping down 200 thousandths, and then we're going back up 100 thousandths, and our operation, as Fusion 360 assumed, is going to be cutting. We're going to press OK. I'm going to turn my sketches off, and notice you should have, if you look in here, you should have a nice grease groove or O-ring groove, whatever the application of this part is for. Lastly, as indicated by the notes, they want us to break the rest of the hard edges on here. Well, we've got one edge here. If we orbit our part around, and we have this edge. So we're going to go up to Modify, down to Chamfer. We're going to click on those two edges to break those. And we're going to type in 10 thousandths at 45 degrees. And this part is looking pretty much complete. It's a good opportunity. Double check your part. Make sure it looks like the blueprint. Make sure you've used all those measurements as stated on the print. This concludes the tutorial for the Titan 86L.